guys, welcome back to my YouTube channel. Today I am going to solve day 31 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. So today I am going to solve problem number 260, single number 3. Okay, so in this problem we have given an integer array nums in which exactly two elements appear only once and all other elements appear exactly twice. Okay, so here see, 1 is appearing 2 times, 2 is appearing 2 times, and 3 and 5 both are appearing just 1 time, right? We have to find the two elements that appear only once. Okay, we have to find the two elements that appear only once, and you can return the answer in any order. Okay, so this is done, right? So here there is one more condition. You must write an algorithm that runs in linear runtime complexity and uses only constant extra space. Okay, so this is a condition given to us. Okay, so see here in the approach 1 I have solved this problem using maps, but in this case both the time complexity and space complexity is of n. Okay, so if you just want to go over this code, then please go ahead. So here what I'm doing here, okay, let me explain as well. So if the nums dot length is equal to 2, then in that case I'm directly returning nums. Okay, so here see, total 2 numbers are there, then we have to just simply return the 2 numbers, right? This is done, and this is given exactly two elements appear only once. Exactly two elements appear only once, so this condition must be satisfied. Okay, so if my nums dot length is equal to 2, then I am always going to return nums. Okay, then in the result I am going to store my answer. Okay, and I am using here I is equal to 0 and count is equal to 0 as constant space. Here I am using the map. Okay, and in this map I am filling the counts of each. Okay, how many times 1 is appearing 2 times, how many times 2 is appearing 2 times, how many times 3 is appearing 1 time, how many times 5 is appearing 1 time. Okay, so this is what I am filling in the my maps, right? And then after that I am iterating over my maps one by one. Okay, and whenever I am getting the value as 1, I am just adding that into my result. Okay, these values into my result here, and once my count reaches 2, then I'm simply breaking it, and in the end I'm returning result. But in this approach my space complexity is of n. Okay, and we need to use only constant extra space. Okay, so definitely we are not going to solve this problem using approach 1. Okay, so now let's move to the better approach 2. Okay, so this is my approach 2. Okay, so in this approach my time complexity is going to be O of n and my space complexity is going to be O of 1. Okay, so this is example 1, right? And here both 3 and 5 are unique, so this is my valid answer, right? So now, so first a few things that we need to know. Okay, so let's me write the XOR table. Okay, XOR table here. So here let's say this is A, this is B, and here I am storing the result. Okay, so if my both values are same, okay, if my both values are same, then in that case what I have to return. Okay, so here see, when we XOR all numbers in the array, every pair of duplicate numbers will cancel out each other. Okay, so here both the values are same. Let's say A is 0 and B is also 0, then my output result is 0 now. Here if both the values are same, then my output is 0. If any value is different, then my output is 1. Okay, this is a few things that we should know, okay, about XOR. So here see, A XOR A is equal to 0. Okay, so whenever two values are same, then their XOR of numbers is going to be 0. Okay, so if I want to write, let's say 2 is appearing 2 times. Okay, if I want to write 2 in binary form, then I'm going to write it like this now. 0 1 0. Okay, this is 1 bit value 2 4. Okay, and again I'm going to write 2 here. Okay, here I'm writing 2, and here also I'm writing 2. Okay, so what is the output that I'm going to get? See, 0 0 0 1 1 is also 0, and this is 0. Yes, so XOR of duplicate numbers will cancel out each other. Okay, so first thing that I am going to do here. Okay, so I hope that you guys are clear that the XOR of duplicate numbers will cancel out to each other. Okay, so now if I do the XOR of all the numbers in my nums array, then definitely 1 is going to cancel out this one, this 2 is going to cancel out this 2, right? And in the end I am only going to left with the 3 XOR 5, right? In the end I am only going to left with 3 XOR 5. Okay, so let's do this. So see here, I am doing the XOR of all numbers. So 1 and 1 is going to cancel out, 2 and 2 is going to cancel out, and in the end I am left with 3 and 5, 3 XOR 5. And what is the output of 3 XOR 5 is 6. Okay, so if I want to write 3 in binary form, okay, so how I'm going to write? I'm going to write 3 like this, right? 1 1 and 0. If I want to write 5 in binary form, then I'm going to write it like this, right? Now let's do the XOR. So 1 1 0 1 0 1 and 0 1 1, right? So this is 6 now, this value is 6, so I'm writing 6 in binary form. Okay, 0 1 0 0. Okay, whatever you want, right? Here it's 0 0. Okay, this bit if you want to take a 4 size, right? So this is how I'm going to write 6 in binary form. Okay, so see here, in the end we are only left with the 3 XOR 5, right? 1 and 1 cancel out each other, 2 and 2 cancel out each other. Okay, so 6 in binary form. Okay, this is done. Now from these two are different numbers now, both of them are different numbers, right? That is why their XOR is not 0. Both of them are different numbers. Okay, so 3 is written like this and 5 is written like this. Okay, so now let's find the rightmost. Okay, from this position let's find the set bit. Okay, what is the first bit that is different? What is the first bit that is different? Okay, so here see, isolating a set bit. So XOR result A XOR B is a non-zero number, right? 3 XOR 5 is a non-zero number because A and B are different, right? So in binary representation, this means that there is at least one bit that differs between A and B. Yes, that is why both the numbers are different. So let's say this differing bit is at position K. Okay, so bit at position K is 1 in either A or B. Okay, so let's say this is my A and this is B. Okay, so the bit at position K is either 1 at either A or B, but not both. Okay, this different bit can be isolated using this method, difference of XOR result and minus of XOR result. Okay, so this operation keeps only the rightmost set bit. Okay, what is the rightmost set bit? So this one is different now, and set all other bits to 0. The resulting bit at position K is going to be set in either A or B and not in both. Okay, so how this is helping? So 6 is my output, right? 6 is my output. So I hope that you guys are aware of this naming 2 complementary. Okay, 2 complementary. Okay, so here how we do this 2's complement. Okay, so first this is my result 6 in binary form. Okay, so I am just going to change all the bits. Okay, so 0 is going to become 1 and 1 is going to become 0 and 1 is going to become 0 in 2's complement. Okay, and 0 is going to become 1. Okay, then okay, this is done. Then after that I have to add 1, 0 1. Okay, carry, and here it is 0 and here it is 1 as it is. Okay, so this is what I am doing, right? I am adding now. Okay, this is done. So this is nothing but the 2's complement of 6. Okay, 2's complement of 6. So that simply means that this is a negative 6. Okay, okay, so see here, XOR of 6 is in binary form is written like this, 0 1 1 0, and minus 6. How I'm going to write minus 6? So to calculate minus 6 we have to use 2's complement of 6. Okay, and this is how we write 2's complement of 6 in binary form, 1010. Okay, this is done. Then after that we have to calculate this difference of XOR result and minus XOR result. So this this and this one, 0110. Okay, 0110. Okay, so let's apply. So here it is going to become 0 and okay, and this is a AND now, both are true, so this is going to become 1, this will become 0, this will become 0. Okay, so this is this difference that I am getting. Okay, so only this bit is set, only this bit is set, right? So we have isolated a set bit. So now after that we have to divide it into the two groups. We can now divide the array into two groups based on whether the bit at position k is set or not. So group 1 is the numbers where the bit at position k is 0. Okay, so what are the numbers we have? We have numbers 1, 2, 3 and 5. 1 is 2 times, 2 is 2 times and 3, 5. Okay, 1 is 2 times, 2 is 2 times and 3 is 1 time and 5 is 1 time, right? These are the numbers now. And how I'm going to write 1 in binary form? I'm going to write 1 like this now, 0 0 0 1. And how I'm going to write 2 in binary form? 0 0 1 0. How I'm going to write 3 in binary form? I'm going to write it like this. How I'm going to write 5 in binary form? I'm going to write it like this. Okay, so group 1 is the numbers where the bit at position k is 0. Okay, so here this is 1 now. 1 is appearing 2 times, so let me write it 2 times. Okay, this is my group 1. Okay, this is my group 1, and group 2 is where the numbers where the bit at position k is 1. Okay, so here this is 2 now, and 2 is appearing 2 times, so let me write 2 times here, 0 0 1 0. Okay, so this is my group 2, right? So here this is done. Now since a and b differ at position k, right, one of them will have the bit set to 0 and other will have bit set to 1. All pair of duplicate numbers will have the same bit at position k. So these are the duplicate numbers now. These are the duplicate numbers. So all pair of duplicate numbers will have the same bit at position k. Yes, they both have same bit at the position k, either both 0 or both 1, and will thus end up in the same group. Yes, both are ending in the same group. Then after that we have to find the XORing property, right? We have to use XORing property. So by XORing all the numbers within each group, in group 1 all pair of duplicate numbers will cancel out each other. Okay, so these both numbers will cancel out each other, leaving only the unique element. Yes, in group 2 all pairs of duplicate numbers will cancel out each other. Yes, they cancel out each other, leaving only the unique number from that group. This is the unique number is left out. So what is this? This is nothing but 5, this is nothing but 3, and 5 3 is my output. Okay, so I hope that you guys are clear with the explanation of what we are doing. Okay, now let's move to the coding part. Okay, first int XOR is equal to 0. Let me increment the size of screen. So first we have to do the XOR of all numbers to get the XOR of the two unique numbers. Okay, this is what we need to do first. So I am going to use for each loop. Okay, this is done. Then after that we have to find a set bit, rightmost set bit. Okay, and how we are going to calculate the rightmost set bit? It is nothing but XOR and of negative XOR. This is done. Okay, so how we are going to calculate this negative XOR? Using 2's complement. Okay, so here I explain 2's complement. Okay, so what do you mean by 2's complement? So first we are going to just replace all the bits. If it is 0 then 1, 1 is 0, 1 is 0, 1, and then we are going to add 1. Okay, this is done. This is done. Okay, so 1 plus 1 is 10, 0, 1 carry, 1 here, 0, 1. Okay, This is done. After that, let's create one variable int result. Okay, result array, and size is fixed, right? Size is fixed to new int. Okay, this is done. Then we have to divide the numbers into two groups and XOR each group. Okay, so let's iterate over all the elements again using for each loop. Okay, so if num and diff, okay, I'm using AND operation. Okay, if it is equal to 0, then the bit is not set in the num. Okay, so in that case, result of 0 XOR is equal to num. Okay, and in the else part, the bit is set in num. Okay, so let's update our result one. That's it. In the end, just return the result. Okay, so this is our piece of code. Okay, now let's run it. So all the test cases has been accepted. Now let's submit it. So see, our solution is accepted and it beats 100% of users with Java. Okay, so I hope that you guys are able to understand today's problem, and if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.